In our last video, we looked at ions, specifically looking at the whole periodic table, locating an atom within the table, and figuring out what would its charge be if it naturally formed an ion. So today we're going to look at these three elements, and we're going to talk about what ion are they going to want to form, and then we're going to identify the subatomic particles that make up that ion. Now remember, ions are charged particles. Cations are the positively charged particles, and anions are the negatively charged particles. So let's start out with calcium. If you haven't done so already, pull out that periodic table. You are going to need it to practice. I do recommend stopping the video if you need to, figuring out, working these on your own, and then seeing how you did. So calcium, let's start out with calcium. Find calcium. It's in that second column on your periodic table. So since it's in the second column, it's going to have a +2 charge. All right, so that is our calcium. I've already put the mass down here. You know how to find that underneath the chemical symbol. We've already put the protons down. You know that's the atomic number, so you find that above the chemical's element symbol. And then we're going to fill in neutrons and electrons based on this information. So with calcium, if it forms a +2 charge, remember electrons are negative species, so it lost negative, so therefore it becomes a positive charge. So with calcium, we have a mass of 40, and we have 20 protons. So to find the number of neutrons, we take the mass minus protons to give us neutrons. So 40 minus 20 gives us 20. Now remember, the reason for that is electrons are so stinking tiny that they pretty much weigh nothing, at least relative to our protons and our neutrons. All right, now what about our electrons? So I had given you this little equation. Charge equals protons minus electrons. And I think that's really helpful to use because if you take our charge, which is our 2+, and that equals our protons minus our electrons, 20 minus an 18 would give us a +2 charge. So 20 minus 18 gives us our charge. And so that's how we're able to figure out how many protons, neutrons, and electrons we have within any given ion. And so to write calcium, you would write Ca2+. Let's do the same for sulfur. So if we look up sulfur on our chart, it's going to form a -2 charge. So with sulfur, you have a -2 charge. So it's going to look like S2-. And yes, in chemistry, we do put the charge with the number first and then the charge. All right, so now neutrons. Do you remember how to calculate neutrons? The addition of protons plus neutrons gives you your mass. So your neutrons, you should have 16 neutrons in this ion. Then our electrons. Remember, protons minus our electrons gives us our charge. And this happens a lot. 18 is a very common number. We'll learn more about why that is later. So protons minus 18 gives us our -2. Now what about bromine? Bromine is in column 7. So when you find it, you should locate it and notice that 8 minus 7 gives me a -1 charge. So this one is going to be 1 negative. Now when we are writing its symbol, you can just put the negative. The 1 is an understood one. So bromine ion looks like that. It's a negative ion, which means it's an anion. Calcium is a cation. All right, let's figure out its subatomic particles. If it's got a mass of 80, then that means our neutrons, we must have 45 of them. And our protons are 35, so those do add up to be 80. Now what about our electrons? So we need there to be one more electron than there is protons, because electrons, once again, are negative, so we know that there are 36 electrons. Does that work with our equation? Yes. Protons, 35, minus electrons, which is 36. 35 minus 36 gives me a -1, and that's my answer. So at the end of this video, I should hope that you know how to look at your periodic table, find an element, predict what charge it's going to form, and use that to figure out what are all the subatomic particles that make up that specific ion.